When people think about sound reinforcement systems, this is what mainly comes to mind. Loudspeakers, and lots of them. Loudspeakers are actually just the final link in a chain of command that begins with instruments and voices being converted into electrical signals by microphones and instrument amps. These individual sounds were then channeled into a mixer for processing and blending, and then the unified mix was fed into an amplifier. What turns all this back into stuff you can hear, i.e. back into acoustic energy, are loudspeakers. What do you really need to know about loudspeakers? Without wishing to minimise the incredible science of loudspeaker design, basically 3 things. What's in them, what's driving them, where you put them. In other words, this scene is just going to explore what makes loudspeakers tick, and what you really need to know and what you can do to get the best out of them. Sound is produced by waves or audio frequencies of many different lengths, from the highs of a triangle to the lows of a bass synth. The human ear interprets these as sound. Frequencies that come as a series of fast, repeating patterns we interpret as high-pitched sound, and those that come as a series of slow repeating patterns as low-pitched sounds. Waves with large peaks and troughs we hear as loud, frequencies that are more ripple than something you'd want to surf on as quiet. In the microphone scene, we saw how transducers convert acoustic energy into electrical energy. So, to answer the first question, what's in a loudspeaker? The main element in a loudspeaker is the driver, which is also a transducer. Only this time, the transducer converts electrical energy back into acoustic energy. These drivers are then mounted into speaker cabinets or enclosures. Simple. Well, not quite, unfortunately. Obviously, you want your audience to hear everything, from the high highs of a ride cymbal to the thump of a kick drum. The problem is that individual drivers are really only capable of producing something in the region of a 3-octave range of frequencies. A single driver is then not going to cut it if you want to deliver a full, rich sound that covers the complete audio spectrum. The answer is to use several drivers, each tailored to reproduce a certain slice of that audio spectrum. Sometimes you'll find 2 or more drivers in a single enclosure, then referred to as a 2-way or 3-way design. And in more sophisticated sound reinforcement systems, you may find several different enclosures, each containing a specific type of driver, like these subwoofer cabs. There are also, it has to be said, many different types of cabinet, from designs where the drivers are pointing straight out, mounted in essentially a simple empty enclosure, to ones where sound is reflected within the cabinet or even travelling through a whole series of chambers before being projected out beyond the speaker grille. We'll let these individual designs convince you, or not, as to whether their particular stylings will do the best job for you. And don't be afraid by this. No one design is best. Sound, as can so many other things in life, can be delivered in a great many ways. Whether you're using single cabs with multiple drivers, or multiple cabinets with individual sized drivers, what you are trying to achieve is a balanced and complete representation of the audio picture. Sound travels in waves or cycles, and in order to reproduce low frequencies, you need to move a lot of air. Putting a deep bass synth through the system, you can actually see air being moved, whereas there's very little coming out of the drivers that handle high frequencies. And indeed, a high frequency sound like a triangle or hi-hat hardly comes through the woofer at all. Drivers designed to handle low lows are normally referred to as subwoofers. What else is there? Drivers designed to handle general low-end frequencies are just called woofers. A mid-range driver delivers mid-range frequencies, and so-named tweeters take care of the high highs. Looking at tweeters in a bit more detail, a smaller driver can deliver high frequencies more efficiently than a larger one. But since these smaller drivers can't produce sound levels equal to the acoustic output of low-frequency drivers, a horn is generally mated to the high-frequency driver to concentrate and control the acoustic energy it produces. Different driver sizes are best for reproducing different audio frequencies. And rather than send out a blanket of frequencies to all of the speakers, a type of filter called a crossover sends specific frequency bands of the signal to the most appropriate driver. Depending upon the system, or the crossover, you may have more or less control over which range of frequencies cross over to the next speaker in your system. Crossovers come in all shapes and sizes. Some are built into the loudspeaker enclosure, which you then have little control over. These are called passive crossovers. Yamaha uses these in the Club series and BR series full-range loudspeakers, simplifying setup and operation. Others might be built into the amplifier, offering some adjustment as to where in the audio spectrum a sound is being divided. Or, on a large system, you'll probably find a separate electronic crossover, which is plumbed into the system between the mixer and the power amplifier. These are known as active crossovers.
Just imagine the same simple speaker system, the 18, the 8, and the tweeter. As opposed to having one amplifier driving those, we have 3 amplifiers that see a crossover before that. So there's one amplifier that powers just the 18, the other amplifier powers just the 8-inch speaker, and another powers just the tweeter. You can imagine the low end is going to take the most power, the mid-range is going to take slightly less, and the tweeter is going to take slightly less than that.
The second of our initial questions about loudspeakers is what's driving them, and the answer to that is an amplifier. Unless you're using a set of powered speakers, i.e. speakers with a built-in amplifier, it's crucial that your amplifier and speakers are compatible in terms of the amplifier's power output and the speaker's power handling. Yes, it's our old friends watts and ohms again, and the whole question of impedance. But first, how do you measure power? Yamaha provides 3 power ratings for loudspeakers: noise, program, and peak. The reason for these ratings is to allow you, the user, to properly put the actual wattage rating into perspective. The noise rating is the amount of power the loudspeaker system can handle if pure white noise, like you hear in between radio stations when you tune a radio, is applied continuously for a period of 8 hours without any signs of abuse or damage. Clearly, this is a torture test. The next power rating is program, which is a more real-world measurement, more representative of real music and speech. Use this rating to determine the acceptable power output of the amplifier you'll need to use with this loudspeaker. Lastly, there is peak power, which is the highest power the loudspeaker can handle momentarily. Operation at these high ratings continuously will certainly damage the loudspeaker system, but it can occasionally accept this power level. What does all this mean in practice? It means that in order to get the best out of the sound reinforcement system, you need to use the appropriate loudspeakers for the amount of power being sent out by the amplifiers. And it means you need to use the appropriately powered complete system for the type of work that you're going to be doing. Okay, so what's appropriate? A little known fact about sound reinforcement is that underpowering, or using an amplifier that's too small, damages more loudspeakers than using one that's too large. So, use great care when matching your speakers and amplifiers. The third question we said needed looking at is where the loudspeakers are going to be placed. Sound, as anyone can tell you who's had their party shut down by police after complaints from residents 6 blocks away, can travel in long and mysterious ways. How sound travels is called dispersion, and it's both an interesting and extremely important thing to consider for a number of reasons. The process starts with the design of the loudspeakers themselves. Notice how this high-frequency horn is flared. This helps the sound develop while controlling dispersion. Next issue is how you position the cabinets to give as many people in the audience a balanced and blended sound. To make the whole procedure as natural as possible for the audience, loudspeakers are normally positioned beside or sometimes above the stage so that the final sound appears to be coming from the stage in one unified direct package. Placement is key to getting the best coverage with the least amount of wasted amplifier power. You need to aim loudspeakers directly at the intended audience. Doing this will avoid 2 major pitfalls. 1, using too much volume, and 2, causing intelligibility problems. Often, novice sound people will immediately go for the master fader on the console when audience members complain they can't hear. This actually might be the very reason for the complaints in the first place. As the sound person, it's your job to understand that the "I can't hear" complaint from an audience member is more likely "I can't understand." This is a common problem in houses of worship, where the audience tends to be a bit older and may be beginning to suffer the early effects of hearing loss. Turning up the sound in a room with a poorly designed or installed sound system is like throwing a rock in a pool of water. The air just becomes full of sound waves travelling in every direction. So how does this relate to loudspeakers? Since the loudspeaker is the place in the system that the signal is actually converted back into acoustic energy, it is also the place where you have at least some control over where this energy gets put into the environment. If you're looking to install a system permanently in a space, you should contact an audio contractor or consultant to help you make the right decisions. And before you do this, why not visit venues that are similar to yours and find out who worked on their systems? Well, provided you liked what you heard, of course. If you're either using a different system every night, or using the same system in a different environment every night, we have plenty of tips on maximising your sound and troubleshooting in the Golden Rules scene. Use speaker cable and don't skimp on it. Loudspeakers are connected to amplifiers using speaker cabling. Even if it can sometimes use a 1/4-inch jack connector, this is not the same as an instrument cable. Use good, thick cable and use a shorter length of cabling as your environment can tolerate. You want to position your power amplifiers as close as you can to the speakers without them being intrusive.
We always try to minimize the amount of cable between the speaker and the amplifier because they sound better. There's no reason to waste your amplifier power heating up the copper in the cable. You want to basically get your amplifiers as close to the speakers as you can. Sometimes when you can't, you need to use the 150s, but anytime you can use the 5 or the 10 footers, it's really the best thing to do.
So to close, here are 1 or 2 specific tips on loudspeakers. 1. When setting up your loudspeakers, make sure they are secure and don't wobble or rattle. Keep cabs that are being placed together nice and tight. 2. If you want to increase the effectiveness of a subwoofer, move it over to where the side wall meets the floor, better yet, the corner of a room. Since this is a place where 90-degree triangles start in the room, you have the start of a large horn. This little trick can be as powerful as doubling your amplifier power. 3. Protect your speakers. Loudspeakers do not appreciate loud audio spikes. Make sure the level controls on your connected amps and mixer are down before you power up or power down. And remember, amps should always be switched on last and turned off first. 4. If your drivers are unavoidably exposed to moisture, do not use them at all until they are thoroughly dried out and preferably checked out.